There is an asteroid that caused astronomers worldwide to simultaneously raise their alert levels. Not because it is the largest, but because it was once calculated to have one of the highest Earth impact probabilities in history. The latest orbital data now show that it will approach Earth again in 2032. This is not a movie plot, but a real astronomical event. A few years ago, when it was first discovered, the risk assessment models produced a highly unusual result. The probability was not high, yet it could not be ignored statistically. This means that although it is not a legendary doomsday killer, it is certainly not a cosmic visitor humanity can ignore. More importantly, as time goes on, this asteroid's orbit is being influenced by multiple gravitational disturbances. Its future path contains subtle yet critical uncertainties. Even a very tiny deviation could determine whether it safely passes by or enters a dangerous corridor. Next, let us take a look at just how dangerous this asteroid really is, what the highest impact probability truly means, and if the worst case scenario occurs, whether humanity has truly been prepared for that moment. Time is slowly closing in. December 27, 2024, an automated sky survey telescope system in Chile, while carrying out a near-Earth object survey mission, issued a global hazard alert. The system detected, at a distance of 830,000 kilometers from Earth, an asteroid whose orbital path had a very high likelihood of colliding with Earth. Astronomers named it 2024 Y24, and the subsequent orbital calculations made everyone deeply uneasy. The data showed that the probability of this asteroid colliding with Earth reached the highest level ever recorded. No known celestial object before had ever been assessed with such a high impact risk. As observational data continued to accumulate, astronomers gradually determined the size of this object with a diameter of only about 100 meters. Although on a cosmic scale such a size is unremarkable, for Earth, however, it would be enough to cause devastating consequences. A research team from Princeton University pointed out that once an asteroid of this class strikes Earth, the energy it releases would rival that of the most powerful nuclear weapons in existence and could completely erase a megacity from the surface. For this reason, this object quickly gained an even more ominous nickname, the City Destroyer. Over the following 2 months, astronomers continued to track it and constantly refined its orbital parameters. In the end, they put forward an unexpected conclusion. This asteroid no longer poses a direct threat to Earth, with the impact probability far lower than initially predicted. However, this brief sense of relief did not last long. New orbital data showed that the orbit of 2024 Y24 will intersect with the Moon's orbit, and its probability of striking the Moon is even higher than its initial probability of hitting Earth. If these predictions are accurate, it would be the most violent lunar impact in the past 5,000 years, and the time could be as soon as 2032. Even if the target is only the Moon, the chain reactions it triggers could still have serious effects on Earth. Research teams around the world focused on planetary defense have already begun proposing various response strategies. One of them sounds straight out of a science fiction movie, changing the asteroid's trajectory through kinetic impact or destroying it outright. If this plan is ultimately carried out, which country do you think would be responsible for executing such a mission? In images captured by the Atlas telescope, you can see 2024 YR4 slowly moving against the background of distant stars. And in the high-resolution images from the Weibo telescope, it appears as nothing more than a faint glowing dot. This asteroid originates from the main asteroid belt of the solar system, located between the orbits of Mars and Jupiter. An astonishing number of celestial bodies gather there, including giant asteroids hundreds of kilometers across, as well as small objects only a few hundred meters wide, like 2024 YR4. At some point, the orbit of this asteroid changed, evolving into a highly elongated elliptical path and beginning to run close to Earth's orbit. This change was no coincidence. The scientific community generally believes that the main culprit is Jupiter. This gas giant is often regarded as Earth's cosmic shield because its powerful gravity can attract and deflect potential impactors. But what you may not realize is that Jupiter is not only Earth's protector, it can also be a creator of threats. Jupiter's gravity can both intercept asteroids and tear them out of the main asteroid belt, sending them into the inner solar system. 2024 YR4 is precisely a product of this mechanism. Under long-term gravitational disturbances from Jupiter, this asteroid broke away from its originally chaotic yet relatively safe orbital region and was flung onto a new, highly stretched orbit. Along this trajectory, 2024 YR4 completes one revolution around the Sun about every 4 years. It was not until 2024 that this object first entered humanity's field of view, at which time its closest distance to Earth was 180 times closer than the Earth-Sun distance. By 2028, it will approach Earth's orbit again. But what truly raised alarm within the scientific community is the close approach 4 years after that. According to current orbital calculations, in 2032, this asteroid will once again skim past Earth's orbit, and that moment is considered the time when the impact risk reaches its peak. While assessing this risk, on February 18, 2025, scientists obtained a disturbing result. The impact probability was 3.1%. This number may not seem particularly high, but it must be noted that this is an object capable of destroying an entire megacity. For a threat of this magnitude, even a few percentage points represent an extremely abnormal and unacceptable level of risk. More importantly, this figure set a new record in the history of human astronomical observations. The previous highest record belonged to the asteroid Apophis, discovered in 2004, whose maximum impact probability was once estimated at 2.7%, causing massive global concern at the time. In the field of planetary defense, there is a very clear criterion. Once the impact probability reaches 1%, a state of high alert and emergency research must be initiated. If this value rises to 10%, then it is almost certain that when you wake up, television, radio, and mobile news notifications will all lead with an official emergency announcement, calling on the public to prepare for the worst. The good news is, as observations and calculations continued, the probability of 2024 YR4 striking Earth was significantly reduced, eventually approaching zero at roughly 1 in 25,000. However, the bad news begins right here. Updated data showed that in the same year, the likelihood of this asteroid colliding with the Moon instead became more severe, with a probability as high as 4.3%. Even more concerning, over the next 2 years, scientists found that this probability could hardly be refined further because 2024 YR4 is too small and too distant, placing it beyond the observational limits of existing telescopes, making continuous tracking simply impossible. Only when it approaches Earth again in 2028 will scientists be able to precisely recalculate its orbit and determine whether the lunar impact risk has changed. This object suddenly appeared, clearly announcing its potential threat, before disappearing once again into the darkness, forcing humanity to remain in a state of uncertainty and wait for several years. Researchers at the University of Hawaii Institute for Astronomy warned that one cannot expect the lunar impact risk to decline naturally like the risk to Earth. According to existing models, 4.3% is not an exaggerated estimate, but a highly realistic assessment, and it does not rule out the possibility of rising further. This is an object that, on record, has never come so close to the Moon before. Even extremely slight external disturbances, such as gravitational perturbations from the Sun or other bodies, could slightly alter its orbit, and such a change could theoretically push 4.3% into a 100% certain event. There is also another, more dangerous possibility that orbital changes could cause this asteroid to point back toward Earth. The distance between Earth and the Moon is only 380,000 kilometers, which is almost negligible on a cosmic scale. Even when approaching the Sun, an extremely small change in speed or direction could cause 2024 YR4 to no longer just graze past, but instead strike head-on. If you think an asteroid hitting the moon is merely an insignificant event, then you are seriously underestimating the risk. Many scientists engaged in planetary defense research have offered extremely pessimistic predictions. Such a lunar impact event could trigger a cascade of chain reactions, not only threatening Earth's safety, but also potentially causing long-term or even irreversible effects on future space missions and launch operations. As for this scenario, we will discuss it in detail later. For now, let us assume the most extreme possibility that this asteroid truly changes its orbit and heads straight for Earth. What would happen? Even in such an extreme event, the scientific community already has clear conclusions. The primary determining factor is the asteroid's size. The larger the impacting body, the lower the chance humanity can survive without paying a catastrophic price. Smaller objects usually burn up through atmospheric friction, disintegrating into fire and dust. But this rule has a clear limit known as the 35-meter threshold, meaning objects with a diameter of 35 meters or more are already too large to fully break up in the atmosphere. And 2024 YR4 has a diameter of about 100 meters, clearly exceeding this threshold and cannot be completely consumed by the atmosphere. The next question then is whether this object would pose a genuine existential threat to humanity. Now let us look back at the asteroid that once caused the extinction of the dinosaurs. This object had a diameter of about 10 kilometers, and the energy released when it struck Earth 66 million years ago is almost impossible to measure by conventional standards. You may have heard of the Tsar Bomba, the most powerful thermonuclear weapon in human history, whose explosive yield was 3,300 times that of the Hiroshima atomic bomb. Yet the asteroid that wiped out the dinosaurs released energy 2 million times greater than the Tsar Bomba, making it one of the most destructive catastrophes in Earth's history. At the moment of impact, Earth was no longer a gentle and life-filled planet, but more like a hellish world you would never want to set foot on. Although 2024 YR4 is far smaller than that extinction-level object, this does not prevent it from still being a threat that cannot be ignored. Some scientists, such as engineers from the Catalina Sky Survey, including David Rankin and his colleagues, used the asteroid's orbital data at the time to outline a risk corridor. This map shows the potential impact zone of that risk corridor, stretching from northern South America across the Atlantic Ocean all the way to sub-Saharan Africa. Of course, it must be noted that if the impact probability changes, this risk corridor could also change completely. Asteroids do not have a fixed impact zone. In theory, the impact could theoretically occur anywhere on Earth. If a collision were to happen, this asteroid, known as the City Destroyer, would enter the atmosphere at a speed almost identical to its velocity in space, nearly unchanged, about 62,000 kilometers per hour, equivalent to roughly 17 kilometers per second. Models show if the entry angle is steep, this object would reach the ground within 10 seconds. What follows is the impact itself. Rather than imagining the scale of destruction, it is better to look back at Earth's history. Similar events did not occur only in the distant past. The location shown is Siberia, Russia. In 1908, an asteroid comparable to 2024 Y224 exploded in this region. This remains the largest asteroid impact event ever recorded in human history. Fortunately, that event did not create a surface impact crater. Instead, it disintegrated in the air at an altitude of 5 to 10 kilometers and exploded. Research suggests that this object had an extremely fragile structure, composed mainly of rock, unable to withstand the intense heat and pressure generated while passing through the atmosphere at high speed, thus triggering an airburst. The shockwave and heat from the explosion were recorded by seismographs around the world. About 80 million trees were destroyed across an area of 2,000 square kilometers. Forest fires spread rapidly. Thunderous booms were heard thousands of kilometers away, and windows shattered in buildings far from the epicenter. From the Atlantic coast to central Siberia, for consecutive days the sky glowed with a faint, dark red light. Fortunately, because the explosion occurred in an uninhabited area, only 3 people were killed that day. People 70 kilometers away suffered severe burns. If we use a single number to summarize the power of this event, the energy released by the explosion was about 1,000 times that of the Hiroshima atomic bomb. Researchers believe if a similarly sized object like 2024 Y224 struck Earth, the level of destruction would be roughly comparable. But this time, the potential impact site might no longer be an uninhabited forest, but a densely populated city. If 2024 Y224 were to strike New York, the consequences would be a disaster of historic scale. If the object is primarily metallic, its structural strength would be significantly greater than that of a typical stony asteroid. It would likely remain intact while passing through the atmosphere and strike the surface directly. If the impact point were in the core of Manhattan, a crater about 1.5 kilometers in diameter would form at ground zero. Landmark buildings within a 3-kilometer radius would cease to exist. Steel frame structures, underground transport systems, and infrastructure would be completely destroyed. As for people in the immediate blast zone, they would not even have time to realize what had happened. The shockwave would rapidly expand outward to a radius of 10 kilometers. Ground surfaces outside buildings would be severely damaged. Windows would shatter. Bridges and elevated roads would collapse. The steel frameworks of skyscrapers could deform. Many high-rise buildings would partially or completely collapse. Within a range of 13 to 16 kilometers, large-scale fires could erupt simultaneously. Theoretical models indicate that the destructive effects of a 2024 Y224 impact could be dozens of times greater than Hiroshima or prolonged nuclear blasts, but without involving nuclear radiation. Based on this risk, global planetary defense agencies have begun discussing the possibility of using nuclear means for deflection or interception. However, current statistical data show that the probability of 2024 Y224 striking the moon in 2032 is actually higher. Unlike Earth, the moon has almost no atmosphere and cannot weaken incoming objects. 2024 Y224 would strike the lunar surface directly. Calculations by astronomers at Princeton University show that the energy released by this impact would be about 600 megatons of TNT, equivalent to roughly 400 times the Hiroshima atomic bomb. The impact site would form at least a crater 1.5 kilometers wide and eject a massive amount of lunar material into space. If the impact occurs on the moon's sunlit side, it would be visible to the naked eye from Earth. Under less favorable conditions, it could still be observed with an ordinary telescope. Scientists point out that this would be the most intense lunar impact event in the past 5,000 years. Most of the ejected material would, under the moon's gravity, fall back onto the lunar surface, but 0.2% of the debris could head toward Earth with a total mass ranging from 9,000 tons to 100,000 tons. All of these fragments would burn up within a few days, forming an unusually intense meteor shower and would not pose a direct threat to humans. The problem is, not everyone is on Earth. Over the past 20 years, there has almost always been at least one astronaut stationed aboard a space station. Although the International Space Station is expected to be retired before a potential lunar impact could occur, China's Tiangong Space Station is still operational and currently hosts astronauts. Studies indicate that lunar debris travels at speeds of about 3,200 to 3,800 kilometers per hour. That is roughly 10 kilometers per second. Although this is slower than typical meteors, it is still far faster than bullets and extremely lethal to spacecraft. What you are seeing here is an experiment conducted by the European Space Agency. A 1.7-gram aluminum sphere traveling at 6.7 kilometers per second strikes an 18-centimeter thick aluminum plate. The result is complete penetration. You might say that lunar debris cannot be as hard as an aluminum sphere. That is indeed true, but consider the much higher speed. These fragments travel at even greater velocities, therefore their destructive power could be comparable to the aluminum sphere in the experiment, sufficient to directly penetrate astronauts exposed in space, leaving almost no chance of survival. Spacecraft and satellites could also be severely damaged or even completely destroyed. For the latter, the situation could worsen further, evolving into an even more catastrophic chain reaction. At present, in Earth orbit, there are about 16,000 artificial satellites in operation, with roughly 2,000 to 3,000 inactive satellites. If some of them are struck and damaged by lunar debris, it could trigger a catastrophic chain reaction. Damaged satellites would break apart and then collide with other objects, creating even more debris. This continuously self-amplifying process is known as the Kessler syndrome. It refers to a state in which orbital debris around Earth exceeds a critical threshold where collisions generate cascading debris, leading to widespread satellite destruction and the creation of new space debris. In this theoretical model, every collision produces additional space debris, the number of fragments keeps increasing, and the probability of accidents continues to rise over time. Once this runaway state begins, satellites are destroyed one after another. Debris orbits Earth at extremely high speeds for decades or even centuries until it eventually re-enters the atmosphere and burns up. During this period, almost all space activity would become impossible. It sounds a bit like the plot of a science fiction movie, with the world on the brink of crisis and the only person who knows how to save Earth forced back into action. Although the Kessler syndrome is theoretically possible, actually triggering such a runaway scenario would require a scale far greater than tens of thousands of tons of lunar debris. Therefore, the probability of this outcome is extremely low. However, scientists have not completely ruled out this science fiction-like extreme scenario. Whether an asteroid strikes the moon or impacts the Earth directly, both scenarios carry extreme risks. Until recently, such astronomical disasters could almost only be faced passively. But today, some scientists have proposed alternative solutions using nuclear means to intervene. Asteroid 2024 YR4 may be the primary potential target of this plan. The basic idea behind this concept is not complicated. Send a nuclear warhead into space, precisely guide it close to the asteroid, and detonate it above the surface. Compared with a simple high-speed impact, this approach can release far greater energy in a shorter time, thereby destroying the target more effectively. Researchers estimate that the explosive yield must be at least 50 times that of the Hiroshima atomic bomb to break the asteroid into fragments that no longer pose a threat, of which most would burn up upon entering Earth's atmosphere. Based on current estimates, if this plan were to be implemented, the time window might fall between late 2029 and sometime in 2031, when the orbit of 2024 YR4 would be closer to Earth's orbit. Of course, this would be an extremely complex and highly risky mission. Any slight calculation error could cause the entire operation to fail. If the first attempt fails, whether there would still be time for a second interception remains a huge question mark. Therefore, acting early while the asteroid is still far away may seem safer. However, long-range interception also has major drawbacks. The farther the target, the harder it is to hit, and the probability of failure rises exponentially. If action is taken only when it approaches lunar orbit, there is almost no margin for error. A single failure would mean the end of the mission. When it approaches Earth again in 2028, scientists will be able to more accurately assess the real probability of it hitting the moon in 2032. Before that, the current probability remains at a historically rare high level. Even so, there is absolutely no need for you to panic. Even in the most dangerous scenarios, humanity would most likely still have ways to respond. At least the real world does not fully follow the plot of the film Don't Look Up. The ending of that sci-fi comedy, to put it mildly, was far from satisfying. But you must clearly understand one thing. As of today, humanity still has no space program that can guarantee with 100% certainty the prevention of an asteroid impact with Earth. We have mentioned many times the massive asteroid that ended the age of dinosaurs, which triggered one of the most devastating mass extinctions. So have you ever wondered if a similar impact were to happen today, whether humanity could survive and what Earth would look like afterward? 66 million years ago, dinosaurs were still the absolute rulers of Earth. They had dominated the ancient continents for over 100 million years, yet they had no idea that a catastrophic disaster was silently approaching from space. A cosmic rock as large as a mountain broke free from the asteroid belt between Mars and Jupiter, leaving its orbit and heading straight toward Earth. After the impact, a crater 185 kilometers in diameter and about 19 kilometers deep was left on the surface. The energy released by that impact not only ended the age of dinosaurs, but nearly wiped out all life on Earth. So if an asteroid of the same size and traveling at the same speed were to strike Earth at the same location today, what would happen? Drawing on our knowledge of ancient impactors and modern scientific technology, we can simulate this doomsday scenario and assess whether humanity would have any chance of survival. The celestial body that changed Earth's fate is known as the Chicxulub asteroid. With a diameter of about 10 kilometers, its speed upon entering Earth's atmosphere reached as high as 70,000 kilometers per hour. The energy released at the moment of impact was equivalent to about 100 trillion tons of TNT, equal to the simultaneous explosion of 2 million Tsar Bomba nuclear bombs. Scientists believe it struck one of the most lethal locations on Earth, the Yucatan Peninsula in Mexico. If the impact point had been even slightly different, Earth's ecosystem today, the evolutionary path of life, and even whether humans exist might all have had a completely different outcome. You might ask, couldn't we have detected such a massive asteroid in advance? The truth is deeply unsettling. Recent studies show that within the solar system, there are lurking thousands of asteroids with unknown orbits, some of which are capable of destroying entire cities or even triggering a new mass extinction. Worse still, these asteroids are often extremely dark and concealed, reflecting very little light and often appear suddenly with almost no warning. A classic example is the first interstellar visitor discovered by humanity, Oumuamua. This object, about 400 meters long and 40 meters wide, shaped somewhere between a cigar and a pancake, is a bizarre celestial body. It was only discovered after it passed the sun, and it reflected only about 10% of sunlight. Although far smaller than Chicxulub, before it was discovered, humanity had no idea it even existed. What is even more chilling is that on October 14, 2017, as Oumuamua passed around the sun and was leaving the solar system, it swept past Earth at a speed of 138,000 kilometers per hour, with a closest distance of only 24 million kilometers. On a cosmic scale, this was almost a deadly near miss. In reality, current Earth-based telescopes are simply unable to effectively monitor objects approaching from the direction of the sun. At the same time, we still lack reliable technology to deflect or destroy a mountain-sized, high-speed asteroid. If the worst-case scenario occurs and a gigantic object is truly discovered heading straight toward Earth, then what you can do may be little more than racing against time to prepare for the impact. Now let us fully simulate such a doomsday scenario. One day in the future, astronomers detect, in the direction close to the sun, an unusual dark spot. It slowly grows larger against the solar background, becoming clearer with every passing hour. The calculated results are despairing. It is a gigantic asteroid 10 kilometers in diameter, traveling at a speed of 70,000 kilometers per hour, heading straight for Earth. It is about 145 million kilometers away, meaning humanity has only 83 days left. Governments around the world try to suppress the news to avoid triggering global panic, but they know full well it cannot last long. Sooner or later, a researcher will leak the information, or it will be discovered by an amateur astronomer and made public. Space agencies worldwide quickly unite, trying to devise effective interception or deflection plans. Gravitational tractors, kinetic impactors, and nuclear deflection plans are proposed one after another, only to be rejected again and again by reality. There is simply not enough time. Generally speaking, an asteroid's speed is determined by its orbital shape and its distance from the sun. Objects in the asteroid belt typically travel at speeds of 62,000 to 90,000 kilometers per hour. NASA's Double Asteroid Redirection Test mission successfully altered the orbit of a small asteroid's moon once before, but that was just a small rock. What humanity faces now is a mountain flying at extreme speed. Nuclear options are repeatedly discussed, but no one can guarantee they would work. They might fail to destroy the target and instead shatter it into countless pieces, which could cause massive impacts across different regions of the globe. In the end, the news fully breaks and the world descends into panic. Cities and rural areas alike fall into turmoil. People struggle in despair amid fear and uncertainty. Official reassurances have almost no effect. People frantically stockpile food, water, and survival supplies. More and more people realize the only possible place to survive is underground. The wealthy are being transferred to deep shelters. Ordinary people desperately rush to hide underground. Highways are completely paralyzed. Everyone tries to flee from the areas predicted by experts as the impact zone. Social order collapses within just a few weeks. Civilization seems to have ended in advance. Only a few hours remain before impact. When the 10-kilometer wide asteroid enters the atmosphere, it looks like a giant fireball devouring the world, setting the sky ablaze. This destroyer slices through the air at 20 kilometers per second. Violent atmospheric friction instantly heats its surface to extreme temperatures. Shockwaves spread in all directions, deafening sonic booms erupt, destroying forests within thousands of kilometers. Glass shatters everywhere. The atmosphere is violently disturbed, the air becomes ionized, and global electronic systems suffer severe electromagnetic disruption. Large numbers of satellites in Earth orbit instantly fail or are destroyed. Television broadcasts and the internet fall silent at the same moment. The world sinks into unprecedented silence. In underground shelters, survivors hold their breath, waiting for the final moment of fate to arrive. Within just a few seconds, this giant asteroid slams into the surface with unimaginable force, releasing energy equivalent to millions of nuclear bombs detonating simultaneously. The crust is instantly torn apart, uplifted, and pulverized, triggering super earthquakes across the globe with magnitudes far exceeding Richter scale 11. The entire planet trembles. These quakes rapidly generate devastating tsunamis. Near the impact site, a giant wave up to 5 kilometers high sweeps across coastal regions. At the same time, massive tsunamis nearly 1.5 kilometers high spread across the world's oceans, engulfing coastlines and coastal cities. The shock generated at the moment of impact hurls about 250 trillion tons of material into the sky. Some of this material reaches temperatures far hotter than the surface of the sun. Centered on the impact site, superheated winds exceeding 950 kilometers per hour expand outward in all directions, covering an area 1,000 to 2,000 kilometers wide. Wherever the fiery hurricanes pass, vegetation is torn apart and life instantly vaporizes. Afterward, vast amounts of blazing magma fragments fall like living rain, covering large parts of North America. Everything within thousands of kilometers is completely incinerated. Forests are ignited, wildfires spread out of control, and continents are engulfed in flames. Meanwhile, dust and debris fill the atmosphere, sunlight is blocked, and Earth enters a prolonged darkness. Massive amounts of dust and cold aerosols rise into the upper atmosphere, triggering a global winter-like effect. Temperatures plummet rapidly. Combined with aerosols produced by the impact and mixed with dust, they form global acid rain and block sunlight. Light can barely penetrate the dust layer. Photosynthesis nearly comes to a halt. Those plants not burned in the initial blasts and heat begin to die off on a massive scale. Worldwide wildfires further raise carbon dioxide levels, triggering an intensified greenhouse effect. Polar ice caps melt at accelerated rates. Vast areas of land are swallowed by rising seas. Ultimately, the vast majority of animals and plants on Earth, even if they did not die in the initial impact, will perish in the subsequent environmental collapse. A new global mass extinction begins to unfold. As for those humans who, at the moment of impact, failed to reach deep underground shelters, the chances of survival are almost zero. And it is no exaggeration to say that the sheer terror of such a disaster is enough to cause some people to die from extreme fear alone. Even for those who successfully avoid the initial impact, the real trial is only just beginning. Due to global devastation, survivors must live in underground shelters for months or even years, depending on how close you are to the impact site. In the initial phase, food and fresh water will rapidly run short. Global supply systems completely collapse. Any resources not stored underground are almost entirely destroyed. Livestock not taken underground under extreme cold and ecological collapse will be completely wiped out within months. The breakdown of the food chain will affect ecosystems across the entire planet. Large numbers of terrestrial plants and animals, as well as marine reptiles and fish, will die as ecosystems collapse, even if they survive the initial impact and shockwaves. For a very long period of time, humanity can only huddle in the dim underground world. The surface world, especially cities near the impact site, will resemble apocalyptic wastelands from movies. Cities near the impact point will be completely erased. Buildings and roads, infrastructure, and natural landscapes vanish instantly. Shockwaves flatten everything, uprooting all trees, leaving nothing behind. Extreme heat ignites city debris and flammable materials, triggering urban firestorms, turning entire cities into infernos. Coastal regions suffer especially severe destruction. Tsunamis engulf and devastate vast urban clusters. Casualties reach astronomical numbers. The vast majority of residents near the impact center die from explosions, tsunamis, fires, or the subsequent environmental upheaval. As for those who survive, they will face an extremely harsh world of severe resource scarcity, food shortages, polluted water supplies, and shelter that is difficult to sustain. Weakened immune systems from stress and malnutrition lead to a sharply increased risk of disease. Setting up basic medical stations becomes crucial for survival. On a psychological level, trauma, loss, and despair will become shadows that nearly all survivors must confront. Without a doubt, enduring all of this would be the hardest survival test in human history. Yet even so, there is still a glimmer of hope amid extinction. Humanity may, in disaster, display astonishing resilience and creativity. The realization of underground hydroponic farming and the development of renewable energy may help sustain the continuation of civilization, provided humanity can unite and cooperate and fully apply wisdom and creativity. Perhaps within about a year, the rebuilding of basic infrastructure could begin. Of course, fully restoring civilization may take decades or even hundreds of years, but without question, the world that emerges from all this will be completely different from the one we know today. Now it is your turn. If a giant asteroid really struck Earth, would humanity still have a chance to survive? If you knew in advance that a massive asteroid was heading toward Earth, what choice would you make? Would you conceal it like the authorities and prepare in secret, or disclose the news immediately, giving people more time to prepare? Share your thoughts in the comments. Thank you for watching this episode. If you enjoy this kind of content, please like, subscribe, and support the channel. See you in the next episode.